Hey Scholars, welcome to Math Savvy. I'm Stephanie, and today we are going to be covering all of the math that you need to know for the Mcat. Yes, I said it, the medical college admissions test, the appalling, the dreadful, and some would even say the most terrifying admissions test. And yes, we are going to cover that today. Here's the deal, Scholars, the Mcat's stressful, but today let's all just take a deep breath. Let's visualize how gorgeous the world is and how much money you're going to make as a doctor. So now, if you don't like math, that's okay. This stuff is manageable for you. My goal for today is to go through tips and tricks to make the Mcat math easier and more approachable. So let's get comfy and cozy with our Mcat math. Okay. So you probably know this, you cannot bring a calculator to the exam. And so our goal is to get comfy with multiplication, division, addition, subtraction. We even have logs, trigonometry, scientific notation. We are going to fine tune those skills. So don't worry if you hate math. I'm going to give plenty of examples, some in the form that you would see on the exam, and some that are just going to help you fine-tune these skills. Let's make it fun and light and let us work through them together, and I will show you how I would approach all of these problems. Okay, so we have pi equals 3.14. We know that. Root 2 equals 1.4, root 3 equals 1.7. And for that, I use the Valentine's Day and the St. Patrick's Day. Valentine's Day is 214, St. Patrick's Day is 317. Okay, and then we have root 23. We know that's in between root 25 and root 16. So I'm not saying that you should memorize root 23. It is important to be able to use this method to estimate the square root of any number. So then root 23 should be in between, somewhere in between 4 and 5. Area of a circle, which is pi r squared. We have circumference of a circle, which is pi times the diameter, or 2 times pi times r. And then I have written out the squares of numbers 11 through 15. And you should be able to recognize the perfect squares of all of these numbers for this reason of estimating the square roots. It will help you down the line. Then we have log 2 is 0.3, log 3 is 0.48. We have log 10, which is 1, and log 1 is 0. So for multiples of 10, we want to count the 0 when it comes to logarithms. So we have log 1, which is equal to 0. We have log 10, which is equal to 1. However, we have log 0.1. We move the decimal once, so it's log of minus 1. Similarly, we have log of 100,000, which is, count the zeros, how many? 5. Good job. And then for log 0.0001, we count how many times we move the decimal. So that is what? You guessed it. It's 4. Okay, also we have fractions that you should just be able to recognize here. Okay, so for the fractions over 9, we want to repeat the numerator infinitely many times. And for example, we have 1/9 is equal to 0.11111, and so on all the way to 8/9 being 0.88888. Boom. So for the fractions over 11, similarly, we take the numerator, multiply it by 9, and repeat it infinitely many times. So for 1/11, we have 0.090909, and so on. 2/11 is 0.181818. All the way up to 10/11 is 0.909090. And no, do not mistake that for 1/11. All right, next, we have the unit circle here. And here at Math Savvy, we love the unit circle. We wish that we could live on her. We love her until the end of time. And yes, she is the end of time. Besides the point. So what is the unit circle? It is a circle centered at 0, radius 1, but just focusing on the first quadrant here, we have 5 angles. We have 0, 30, 45, 60, and 90. And we need to know the cosine and the sine values of these angles. That is, we need to know the x value and the y value of these angles when it comes to the unit circle. So cosine is the x value, sine is the y value, and I wrote out the numbers that you need to memorize here. Now say we have a little line and it lies on the 30-degree angle, but no, it is not of length 1, it is of length 2. So what do, you may ask? We want to find the x and y values, or the legs of the triangle. All we have to do is multiply the standard unit circle cosine and sine values by the length. Does that make sense? So we have 2 times cosine of 30, which is 1.8, and I'll let you guys try the y value. You should get something looking like 1. Good job. Okay, I am now going to talk about a good way to memorize the sine and cosine angles in a way that I have never failed to forget these values. If you're like, Steph, you're making it too complicated, what the heck, then skip to the next timestamp and I will be with you shortly. All right, so this is called the left hand rule. This is my left hand next to my Mary painting because yes, she's dope and love this painting from the 99-cent store. Anyways, let's draw these 5 angles that we just talked about. 0, 30, 45, 60, and 90, all in the first quadrant. Now I want you to focus on 60 degrees. The cosine of this angle is going to be the square root over the number of fingers to the left, or over the angle that we're talking about, over 2. And similarly, the sine is going to be the square root of the fingers below the 60-degree angle over 2. So cosine is going to be 1. The square root of 1 is 1/2. The sine of this angle is going to be root 3 over 2, which is about 0.9. And here are the accurate results there. And then let's try the 45-degree angle. Yes, you guessed correctly. It's going to be root 2 over 2 for both the cosine and the sine angle, which completely makes sense. That's going to be about 0.7. And then if we focus on the 0-degree angle, we have 4 fingers above the 0-degree angle. The square root of 4 is 2. We put that over 2, we get 1. So the cosine of 0 is going to be 1, while the sine of 0 is going to be 0. Okay, so in the Mcat, you want to estimate and round whenever you can to make the math easier. And this is something that you should practice because you want to focus more on the conceptual side of things rather than making simple mistakes. So I'm going to give you some problems here. So when you round, you want to make sure to round in the same direction if you are dividing. It doesn't matter if you're multiplying, adding, subtracting, whatever. But these are for reasons that I'm not going to get into because ain't nobody got time for that. Trust me, it'll be more accurate that way. So here are some examples with tricks that I found has helped me expedite the arithmetic process, and I found it helps me, so maybe it helps you. So let's do multiplying. 45 times 21. 45 times 20 plus 45 times 1 is how I would do it. We want to separate one of the numbers by the tens and the ones to make that easier. So we get 900 plus 45 equals 945. So that made things a lot easier. Let's do 56 times 84. Okay, easy. Let's just do 50 times 80 and 6 times 4. No. That is a mistake. We can only separate the tens and the ones of one number, not 2. So we get 56 times 80 plus 56 times 4. Then we can separate them again to get 50 times 80 plus 6 times 80 plus 50 times 4 plus 6 times 4. And then, long story short, we get 4,704. But you will not see anything like that on the Mcat. I just put that there so you don't make mistakes like that. Let's move on to division. Okay, we have 7.5 divided by 15. We're going to recognize that 75 divided by 15 is 5. So I'm going to move the decimal of the dividend to the right once. And then we get 5. We move it over to the left once. And we get 0.5. Easy, call it a day. Okay, 0.24 divided by 30. I'm recognizing that 24 divided by 3 is 8. So I'm going to play with the decimals. We move over the decimal of the 24, right, 2 times. We move over the decimal of the 30 to the left once, and that translates into moving the decimal of the quotient to the left 3 times. Yes, that's confusing, but let me explain. So when you manipulate the decimals of the divisor, which is the 30 in this case, we moved it over once. We're going to move it over in the quotient the same amount of times in the same direction. That's just how it is. So we do 0.24 divided by 30, which is 0.008. And we got a very small number, which makes sense because when you divide a small number by a big number, we're going to get a small number. Fact checking ourselves, you see. Okay, 4 divided by 1.33. We are going to recognize that 1.33 is what? 4/3. Good job. So yes, you want to brush up on your fractions here. We are going to multiply by the reciprocal when we divide fractions. Yay. So 4 times 3/4, cancel out the 4s, we get 3. Moving on. So 32 divided by 0.88. We talked about this in the beginning. 0.88 is about 8/9. So let's do the same thing. 32 times 9/8. Cancel out the 32 and the 8 to get 4 in the numerator. 4 times 9 is 36. Good job, my friends. I'm going to let you try these 2 problems, and I'll be right here if you need help, you know? Bye. Okay, welcome back. Here are the solutions. You got this. This was a test to see if you can remember common decimals and turn them into fractions, because that will make it easier for you guys. Anyways, tip number 3. You're already a scientist. You already know how this works. The Mcat people, they love scientific notation. So we want to brush up on those skills. So here are a couple of examples. Let's do it. 3.5 times 10 to the minus 8th divided by 5 times 10 to the minus 4th. So let's move the decimal over. So we get 35 times 10 to the minus 9th divided by 5 times 10 to the minus 4. We get a 7 here. 7 times 10 to the minus 9th minus 4. And we get 7 times 10 to the negative 5. Good job. Okay, next problem. Let's turn the left side into a scientific notation. So let's do 4 times 10 to the minus 3 times 5 times 10 to the minus 5. 20 times we add the 2 exponents of the 10s to get minus 8. Yay! Okay, we get 20 times 10 to the minus 8th, or if you're special, we can do 2 times 10 to the minus 7th. Yes. Okay, 1.1 times 10 to the 3 times 2.5 times 10 to the 9th. Let's combine these skills that we just learned, okay? So I'm going to do 1 times 2.5 plus 0.1 times 2.5 times 10 to the 12. Okay, so we get 2.5 and then plus 0.25. And what we did is move the decimal over once when you multiply something by 0.1. Easy. We get 2.75 times 10 to the 12th. And yes, we just added those exponents. Easy. So here are some practice examples to do on your own. Pause it, do them, and remember about rounding. And I will be right with you shortly. Break a leg. Okay, welcome back. Welcome back, my friends. How did we do? We can round. We did some rounding. I hopefully see some rounding from you guys. Okay, let's play. Let's get let's apply our skills, you know. So we're going to do 2 general chemistry problems. Find the molar mass of, is this iron sulfate? Sulfite? Who knows? You know, because you're a scientist. Anyways, I have all of the molar mass of these 3 molecules here. So what are we doing? We're adding and multiplying. And let's do it. 2 times 55.85. I'm rounding up to 2 times 56. We are doing 2 times 50 plus 2 times 6. What do we get? We got 112. Good job. 12 times 16, because there are 12 oxygen molecules here. So we're going to do 16 times 10 plus 16 times 2. We get 160 plus 32 equals 192. Then finally, let's do the sulfur. We get 3 times 32.07. We're just rounding down here. 3 times 32, we get 96. Okay, so let us add all of these together. I'm just doing quick math. We get about 400. And what's the actual molar mass? 399.88. So that's not too far off. We can do some rounding, you know. Let's do the second problem. How many molecules are in 15.75 grams of H2O? All right, my friends, we have a little bit more to do here. I wrote out the molar mass of H2O here. We're always going to make a game plan before we start. We have grams, we're trying to find molecules. And by thinking so hard and deep about this, we can do grams to moles to molecules. That makes sense. We have all of the conversions here. So I'm going to start with 15.75 times 1 mole over 18.02 grams, which is converting to moles. We cancel out the grams. Then we multiply times the molecule number to cancel out the moles. And what I'm going to do here is I'm recognizing some, you know, easily canceled out figures here. So I'm going to recognize that 18.02 is about 3 times 6.02. So I'm going to cancel out the 6.02. Cannot cancel out the scientific notation here. And I'm going to cancel out the bottom, which is 3. So as for the arithmetic, all we have to do is 15.75 divided by 3. We can do that. 15 divided by 3 is 5. 75 divided by 3 is about 25. Okay, boom. We get 5.25 times 10 to the 23 molecules. We did it. That's not too bad, is it? Is it bad? I don't think so. Let's talk about fractions and ratios. Percentages here. When you are taking percentages, I like to compare them to the 10% because 10% of anything is easy. You just move the decimal to the left once. Easy. So 10% of 76 is 7.6. 20% of 48 is 2 times 4.8 because 10% of 48 is 4.8. Multiply it by 2. 9.6. Easy and accurate, right? 90% of 50, we are going to take the whole number and then subtract by 10% of the number. So we get 45. Boom. 5% of 94, we are going to do the 10% of the whole number and divide it by 2. And we get 4.7. Fractions, yes, let's add them. 2/3 plus 2/9. We're going to find a common denominator. The 3 goes into 9 3 times. 2 times 3, we get 6. So we get 6 plus 2 equals 8/9. 5 6 plus 3/10. Oh, let's find a common denominator here. Let's do 30. Let's multiply the 5 times whatever it takes to get the 6 and the 30. We get 5 times 5. Same with the 3. And we multiply that by 3. We get 25 plus 9 equals 34. Okay, scholars, I know what you're thinking. Steph, why are you teaching us fractions like this is 5th grade? No, this is not 5th grade. This is some serious stuff. What I really wanted with this is to get the point across that we do want to practice our simple arithmetic, you know? It's important, and you will see what I mean in the following example. Okay, let's do an application of the thin lens equation. So a virtual image is formed 8 centimeters from a convex mirror with a focal length of 10 centimeters. How far from the mirror is the object that created this image? So I wrote down the equation here, 1 over f, where f is the focal length, equals 1 over O plus 1 over I, where O is the object distance and I is the image distance. Since we're scientists and scholars, we know that a virtual image implies that the I is negative, and a convex mirror also implies that the f is negative. Let's plug these in. We have minus 1 over 10 equals 1 over O minus 1/8. So let's move the 1/8 to the other side. We get minus 1/10 plus 1/8 equals 1 over O. We are going to have to do some addition of fractions. Oh my gosh, let's do it. Minus 4 plus 5, that's 1/40. And now we are solving for O. So O is equal to 40. Therefore, the object distance is equal to 40 centimeters, and that is an option here. Period. Okay, let's take a pause here. You guys are all killing it. We're all basically math nerds by now. Don't forget to like and subscribe and leave a comment below if you want us to do ASMR content. We're really thinking about it. Let me know. Tip number 4. This is where I write out 6 different exponent rules. You probably know them, but these are just things that we are going to be using for sure when we study for the Mcat. Here we go. Okay, we already discussed the approximate logs that you should memorize, but let me go more into detail about what this log actually means so you can kind of remember this stuff more easily. So what is a log? A log operation is to exponents as multiplication is to division. So most of the time you'll have the log equation and you'll want to convert it to the exponential equation to make things easier and to find the answer to the problem. You'll see what I mean when I go through an example, but here are the rules for the logarithms. Okay, so log to the base a of y is equal x, which means that a to the x is equal to y. So I just would memorize that. That is something that is gonna help you, and you'll see what I mean later. So the log of any base of 1 is equal to 0, and log of any base of itself is equal to 1. Easy, makes sense. Log, this is what you'll really need to know. Log of a times b is equal to log of a plus log of b. Log of a over b is equal to log of a minus log of b. And commonly, when you just see a log, that is log 10. And then if you see ln, that's called the natural logarithm, and that is log of the base e. Make sense? Good. It's time for an application. Okay, we have a solution, right? We have a solution of acetic acid, and we have the pK here, and we know that it has a pH of 6.75. The ratio of acid to conjugate base is, let's find out. Okay, so this is called the Henderson-Hasselbalch equation. pH is equal to pKa plus log of the concentration of the base over the concentration of the acid. So let's just plug in what we know. We have 6.75, which is equal to 4.75 plus log of the base over the log of the acid. Subtracting 4.75, we get 2 is equal to log of the base over the log of the acid. Let's convert that. We know how to do that. Let's convert it to exponential form. So we know that 10 to the second power is equal to the concentration of the base over the concentration of the acid. And what we're trying to do is find the acid to the base. So let's flip all of these around. We get 1 over 100, which is equal to the concentration of the acid over the base. So I'm not here to teach you science, guys. We have to know which one is the acid and which one's the base. We recognize that it's 1 acid to the 100 base form. So we found the right answer. Good job. So yeah, we use the rule of logs there to convert it to the equation that we can recognize, and we found the answer from there. All right, guys, this is trigonometry. Here at Math Savvy, we're calculus mommies. We endorse trigonometry. We love it. And you know what? Triangles are awesome. The right triangle has done wonders for this world. You know what I mean? So you'll be tested on this stuff. We need to know sine, cosine, tangent. And we already talked about the values in the beginning, but let me talk about what these things really mean. Okay, we have a right-angled triangle, usually with the unit circle and XY plane in reference, but here we go. So we have an angle, and then we have 3 sides. So SOHCAHTOA, we have sine opposite hypotenuse, which is sine equals opposite over hypotenuse. And then we have cosine, which is A over H, tangent, which is O over A. And I wrote out what these sides are in relation to the angle. So for the Mcat, we should know the difference between vectors and scalars in the context of kinematics. So vectors have direction and magnitude, whereas scalars only have magnitude. We can think of this as distance being a scalar, displacement being a vector. Similarly, speed could be a scalar, and velocity is a vector. So let's do an example. A girlie walks 3 meters in the westward direction to order a skinny marg, then turns around and goes 8 meters in the eastward direction to find her homies. What is her total displacement? Let's draw a diagram. 3 meters west, 8 meters east. So we see from her starting point, her total displacement was 5 meters east. But the distance is something else. So we see the distance, which has no direction. It's just paying attention to how much she walked, being 3 meters and then 8 meters, which is 11 meters. Suppose we have another girlie traveling 6 miles east, then turning to go 8 miles north. Find the total displacement of the girlie by drawing a diagram. Now, we could recognize that 6 squared plus 8 squared, take the square root of that, is 10. So we know that the hypotenuse of this right-angled triangle is 10, and that is the total displacement. And the direction is in the northeastern direction. But, you know, we can find an angle too. So you get the idea. Let's put all of this together with an application. So I have 2 examples that I pulled directly from Practice Mcat, and then I have a final example of the day that is just going to help us learn kinematics overall. So we have 2 vectors of magnitude 8 units and 5 units, making an angle that form anywhere from 0 to 180. So it could be from 0 and they could be pointing in opposite directions, or it could be 180 and they're pointing in the same direction. The magnitude of the resultant vector a plus b cannot have the value of. So for this idea, we know that the resultant vector cannot be less than a minus b or more than a plus b when it comes to their magnitude, okay? So the magnitude of a plus b is 13, and the magnitude of a minus the magnitude of b is 3. So we can see that 3 of these values lie in between that limit. We get that 2 cannot be the magnitude of the resultant vector. Does that make sense? A boat sails straight north at 10 knots for 10 hours, which is nautical miles. Good job. As it sails, a steady whine comes from the east at 5 knots. If the helmsman makes no correction for the wind, where will the boat be compared to its starting point? All right, so just looking at this problem, let's cancel out some things. So we know that it cannot, the ending point cannot be directly north because we have a wind coming from the east. So it can't be choice A, it can't be choice B. So is it C or D? If it's coming from the east, that means it will end in the northwest direction. So we already have our answer here, but say I wanted you to find the number. Let's just do it for fun and games, you know, for S and G's. Let's find the direction north. So if it's going north at 10 nautical miles per hour for 10 hours, cancel out the hours, we get 100 nautical miles. Similarly, for the westward direction, it's going 5 nautical miles per hour for 10 hours, we get 50 nautical miles. Let's draw the diagram. It's going 100 north, 50 west, because it's coming from the east. And let's find it. We're doing the Pythagorean theorem, and we get 111.8, which is very close to 112. Good job. All right, next problem. This is a very complicated problem. As I said, this isn't going to be something that you're expected to do for the Mcat. However, if you practice problems like this, you will be tested on components of this problem, and it is a long problem. So let's tackle her. Let's do it. I drew a diagram here. We are going to find the total displacement from the starting point. So 42 meters in the 30-degree angle relative to the x-axis, and then 19 meters, so turning in a 90-degree direction in the 120-degree angle relative to the x-axis. So finding displacement. So firstly, let's just focus on the first vector in the x direction. So we take the magnitude and multiply it by the cosine of the angle. So we do 42 times cosine of 30. We know that. We do 42 times 0.9. How we're going to do that is do 42 minus the 10%, which is 4.2. We get about 38. Similarly, let's do the y direction using the sine angle, the sine of the angle. And so 42 times a half is 21. And I'm going to do the same thing for the second vector, for R2. And we are recognizing here, we are paying attention to the direction. We are recognizing that the x value is going to go to the right and then to the left. So when it goes to the left, it's going to be negative, right? So we're going to insert that negative here. So minus 19 times cosine of 60 is minus 9.5. Same thing for the y direction for the second vector. So let's find the sum of all of this. For the x direction, it is going 38 meters to the right and then 9.5 meters to the left. So overall, it's going 28.5 meters to the right. And for the y direction, it's going 21 meters up and then 17 meters up again. So we get total 38 meters. And what have we found? We found the x value of what the total displacement was and the y value. So we already know how to find the hypotenuse of this right triangle. The Pythagorean theorem. Good job, you guys. So I'm going to do this. 28.5 squared plus 38 squared. Doing the math, as I said, you probably won't have to do this crazy math like this. We get 2250, which is about 47.5 meters, which makes sense. It totally makes sense because you're going 42 meters at a angle that's closer to the x direction, and then 19 meters back. So it makes sense that the total displacement was 47.5 meters. Okay, so as I'm editing this, I'm realizing that we could have just used the Pythagorean theorem in the first place because it was already in a 90-degree angle to measure the hypotenuse. However, you know, we learned something from this, and I thought that example was helpful in remembering how to do kinematics, so I hope that helped. Well, that's our last example, guys. I really enjoyed making this, and let me know if you want more Mcat content. I started college as a chemistry tutor, and I loved it. But then once it got to the molecules and less on the math, I was like, you know what? Don't want to do this anymore. Let's go full on math. You know, 'tis the season for math. So. Anyways, thanks for stopping by, Math Savvy, and I hope you have the best day of your life. I mean, even better than yesterday or the day before. Like, life is good, right? Anyways, bye, guys.